This lesson is about a completely different way of combining objects. You can combine completed polygons into a single area object in a way that is completely different than the way we have been combining them into a general path. In area objects, the shapes are painted one on top of the other according to the rule that you set, and then, when you display the area object, you get the resulting shapes that were combined according to that rule. Probably the only way to understand this thing is to see an example. First, let me show you what I'm trying to do here. This is the window produced by the program I'm about to show you. At the top, you see the two fundamental shapes being combined, a rectangle and an ellipse. The rest of the figures on the page show the two shapes being combined and then displayed in two different ways. Here's how that's done. The two shapes that are to be combined are stored here. Once they are constructed, the two are combined by inserting the ellipse into the box. Here's the method, make parts, that's used to construct the two new shapes. Now, this is the code that draws the two shapes at the top of the window. First, a call is made to make parts to create the objects. Next, a transformation is put into the graphics object so the drawings will appear at the right place. And finally, a call is made to the draw method to draw the two figures. They both use the same affine transform, so they show up in the same place. This code starts off by a call to make parts. Then a call is made to the add method of the box object, which adds the information from the ellipse object into it. The rest is drawing. The resulting combination, which is stored in the box office, has its outline drawn on the left and then has its interior filled on the right. This code does the same thing, but the rule combining the two figures is different. Instead of just adding the two together, this one combines the two by using the exclusive OR rule. The resulting figure consists of any place that one or the other of the figures show up, but not where they both show. The next rule is the intersect rule. The result is only the portion where they both happen to appear. This is the least intuitive of all of them. I don't quite get this one myself. I'll show you the figure again here in a minute. This is a subtraction. That is, the ellipse is subtracted from the box, leaving only the portion of the box where the ellipse does not appear. And as I'm sure you remember, subtraction is not commutative. That is, the order of the subtraction matters. In the previous example, the ellipse was subtracted from the box. In this example, the box is subtracted from the ellipse. The results are the opposite of one another. Now here are the shapes again. The simple shapes are drawn at the top center. The ones right below it are the result of adding the two together. The result is drawn on the left and then filled on the right. The next row shows what happens when the two are exclusive ORed together. The middle portion is missing when the resulting shape is filled. The next one is the intersect. The one on the right makes sense, the area where the intersect is filled. But the one on the left doesn't look quite right. It's been working this way for lots of years, so I guess it is right. I just can't quite see the logic of it. Okay, now you've got several ways to combine objects. You can just paint them on, or one next to the other, or you can use transparency to look through one to the other. You can combine their diagrams in a general path, or you can logically manipulate their shapes into an area object. And you can use all of these things in any combination. All in all, you're able to do just about anything you'd like to do. You should be able to paint things just about any way you want. Now, if you really want to get complicated, don't forget the pixel by pixel stuff that I showed you earlier.